Hi there. As we started with data flow, and we'll look at an example, before that, let's take a quick detour. And what I would like to go through is some of the metrics that are useful when it comes to path-based testing. And those would be useful even when we're thinking from a data flow perspective. Hence, we are taking this small detour. So this is path-based testing and the metrics for it. So as we looked at the code-based testing part, a quick review would be around statement, branch, multiple condition, loop, modified path testing, etc. I think we would have realized that there is a lot that can be done just by knowing how the code looks like and how math sees it. That's the graph part of it. But all said and done, we do everything wherever there is a measurement. And if there is no measurement, you cannot control. So this is what H. James Harrington says. Measurement is the first step that leads to control and eventually to improvement. If you can't measure something, you can't understand it. If you can't understand it, you can't control it. If you can't control it, you can't improve it. So I think what we are really looking at is metric which will lead to improvement. So what we really want to do is measure, understand, control, improve. MUCI. Measure, understand, control, and improve. So that's the logic, that's the philosophy that we'll follow. And this is the metric that we have, which is given by Miller's test coverage metric. And we'll quickly go through each of these. So we have got every statement, that's what we look at. Every DD path, decision to decision path, every predicate to each outcome path, coverage plus loop coverage. So we have C1 coverage, that is C1 coverage plus loop coverage. We have C1 coverage plus every dependent pair of the decision path. Then we look at multiple condition coverage, CIK, which is every program path that contains up to k repetitions of a loop. K repetitions of a loop. CSTAT, statistically significant fraction of paths. In those many paths, some are statistically significant. C infinity, all possible execution paths. This would give you an overview of how much can be measured, and each measurement can lead to certain analysis. Like every statement, every DD path, every decision path, every predicate to each outcome. Each of these would mean something. Each test case that we design would lead to finding an anomaly, which would then lead to finding a defect or just wrong logic. So this is what we should remember. In fact, this is all on one slide. It would be nice for you to take a print and look at it whenever you're doing path testing related work. So that's what we had in 6.2. We await 6.3 where we're going to discuss an example on data flow testing. Thank you.